All right, this is an application of related rates. First thing we do is read the problem, see what's going on. The area of a circle is increasing at the rate of 200 square feet per minute when the radius is 20. How fast is the circumference changing when the radius is 20? So we need to write down the information we're given. The area of a circle is this. So first of all, what's the formula for the area of a circle? It's area is pi r squared. Well, the rate at which the area is changing is this. Well, what is the rate at which the area is changing? It is dA dt. That's what, in calculus, that's the rate at which the area is changing with respect to time is 200 square feet per minute. Okay, this is when r is 20. Then what we want to know is how fast is the circumference changing? Well, the rate at which the circumference changing is dc dt, and remember the circumference of a circle is 2 pi r. All right. This is what we're trying to find when the radius is 20. So now what do? Well, we know what dA dt is when r is 20, so let's take the derivative here of this right here. So we'll kind of square this off. So the time derivative, we're taking the time derivative of our area equation of a circle. The derivative of the area is dA dt. We did this in the last video. The derivative of this is 2 pi r to the 1, but then we got to multiply by the derivative of r by the chain rule. The derivative of r with respect to t is dr dt. Now let's plug in what we need. So notice over here, if I take, this is what we're trying to find is the time derivative of this. If I take the time derivative of this, what do we get? Well, the time derivative is 2 pi times the derivative of r, but the derivative of r is dr dt. So the only thing we need to know here is what is dr dt. So when I plug this information in, dA dt is 200 square feet per minute equals 2 pi times r is 20 feet, times dr dt. Now I can solve this equation for dr dt when r is 20, plug it in here, and I can find dc dt, the rate at which the circumference is changing when r is 20. So that's all we got to do. So what do we get here? We get 200 square feet per minute. We're solving for dr dt, so we end up with 40 pi feet when we divide by that. 40 goes into 25 times. 40 goes into 200 5 times. So we're left with 5. Now notice the feet here. We get 5 over pi. One of these feet cancels with these, yeah, and we're left with feet per minute. And I guess I should say when I divided by that, what we found was dr dt. We just divided both sides by that to get this. So dr dt is 5 over pi feet per minute. Now notice the radius, that's just a distance. So these units make sense. Feet per minute, that's the units for changing distance. Yeah. Square feet per minute is area changing. Cubic feet per minute would be volume change, the rate at which volume changes. So keep an eye on your units, make sure they make sense. So now we just plug that in here. So the rate at which the circumference is changing when the radius is 20 is 2 pi times dr dt. Dr dt is 5 over pi feet per minute. The pi's cancel and we're left with 10 feet per minute. So that's the rate at which the circumference is changing when the radius is 20